All right, so now we are starting chapter 2. And we'll start with section 2.1, which is entitled Linear Equations and Rational Equations. So taking a look at this, our objectives for this section are we are going to look at solving linear equations in one variable. We're going to look at some of those equations when they have fractions and how to solve them. We're also going to solve rational equations with variables in the denominator. We want to be able to identify the difference between what is considered an identity, a conditional equation, and an inconsistent equation. And we are going to solve applied problems using mathematical models. So those are the objectives for section 2.1. And we will start by talking about the definition of a linear equation. So it says here that a linear equation in one variable x is an equation that can be written in the form of ax plus b is equal to 0. And that is where a and b are real numbers. So these are not going to be letters. These are going to be real numbers. So I'm going to say here where a and b are real numbers. And also we have a stipulation that a cannot be equal to 0. Because if a was equal to 0, then this term would be 0 times x, which would just be 0, and then we wouldn't have a linear equation. Let's fill in the blank here. It says an equation can be transformed into an equivalent equation by one or the more of the following operations. So we can simplify an expression by removing grouping symbols and combining like terms. So what do they mean by like terms? What does it mean to have like terms? So like terms, those are terms that have the same variable and the same exponent on that variable. If you have both of those happening, then you have what are considered like terms. And what you can do is you can combine their coefficients. The coefficient is the number that is multiplied by the variable. It's that number that touches the variable. So, for example, if you saw 3x squared plus 7x squared plus 5x, you would look at this and you would say, okay, there are 1, 2, 3 terms here. Terms are separated by either a plus or a minus sign. So here we have 3 terms. All 3 of these terms have variables in it. All 3 of them have x's, but only 2 of them are alike because they have the same exponent on the x. These 2 have an exponent of 2. This one, the 5x, has an exponent of 1. Even though the exponent's not written, when it's not written, the exponent is 1. So what I can do for these 2 is take and combine the 3 and the 7. And then I rewrite the variable with that exponent attached. This would be the simplest that I can make this expression. I can only combine the front 2 terms here because they are like terms. I cannot combine it with the 5x. So this would be the simplest I could make it. So when you combine the coefficients, like I did here, 3 plus 10, you combine the coefficients and you rewrite the variable with the same exponent. So notice how I didn't change the variable. I didn't change the exponent. I rewrite the variable with the same exponent. I'm not adding the exponents. I'm not multiplying the exponents. I am just rewriting the variable with the same exponent that it started with when I'm combining like terms. So let's go back to our list here. And so step 1 is to simplify an expression by removing grouping symbols and combining like terms. Grouping symbols are like parentheses or brackets. Then I'm going to add or subtract. I can add or subtract the same real number or variable expression on both sides of the equation. That means that if I had, let's say I had this, and I wanted to move a number over to the other side of the equal sign. Well, that means that I could add the same number or subtract the same number from both sides, and it keeps the equation the same. So if I was to want to get x by itself and I wanted to say this is x plus 7, so I'm going to subtract 7. What I do to one side, I have to do to the other, and it keeps the equation balanced. So you can add or subtract the same real number or a variable expression on both sides of the equation. It will transform into an equivalent equation. And this helps us in the solving process. You can also multiply or divide by the same non-zero quantity on both sides. So notice how these are emphasizing both sides, because what you do to one side, you do to the other side, and it keeps the equation balanced. So if I had this, and I wanted to say, okay, this is x divided by 4, I'm going to do the opposite of dividing by 4. I'm going to multiply by 4. As long as you do the same thing to both sides, it keeps it an equivalent equation. So here I would hit 4x divided by 4. The 4's would divide out to 1, and I would get x is equal to 40. So this helps us in the solving process. And then the last one here, it says here you can interchange the two sides of the equations. And we saw this in the last unit where when we were finding the inverse, I was saying that you can swap the two sides. You can move when you ended up with a y on the right hand side, you could swap the two sides. So for example, let's say that you had this. You can write this like this, swapping or interchanging the two sides. And it's still the same, it's the same equation. So I didn't change anything. All the signs are the same on both of them. I just interchanged the two sides of the equation. So when we go to solve a linear equation, we want to simplify the algebraic expression on each side by removing the grouping symbols and collecting like terms. We want to collect all the variable terms on one side and all the numbers or constant terms on the other side. So when you see numbers, they are the same as saying constant terms. Variable terms are the terms that contain a variable, a letter, an x. So we're collecting all the variable terms on one side, we're collecting all the numbers on the other side. Then we want to isolate. When we're solving an equation, we're trying to isolate the variable. Get the variable by itself on one side and solve. And then lastly, we want to check the solution in the proposed solution in the original equation. So we want to go back to the original equation and check if it is correct. So we'll take a look at some examples of that too.